recording. I remember last class we did not cover this example. When we practice problems regarding compound interest, we didn't have the time to cover a case in which the future value of the account is given and we are looking for the present value of the account. So let's look at this problem together before we move to the new section. How much money should be deposited today in an account that earns 6% compounded monthly so that it will accumulate to 20 grand in 5 years? So this problem gives us a financial goal. The financial goal in 5 years is 20 grand. So let me write it down. What do we have? The financial goal A is 20 grand, and the annual interest rate R is 6%. Interest is compounded monthly, so N equals 12. All right, so let me show you how do we find the amount of money we're supposed to deposit today in order to reach a certain financial goal in a certain time period. So this is a discounting process. We are going to use a discounting process. Discounting process applies when we go from the future value of the account to the present value of the account. So firstly, I'm gonna write down monthly on a scratch paper. Remind myself the interest rate, the interest is compounded monthly. So the discounting factor, you might remember last class we had a concept that is called compounding factor. Okay, compounding factor is 1 plus rate, and the rate depends on how the interest is compounded. If the interest is compounded monthly, then the rate here is the monthly interest rate. And 1 plus R over 12 here is the compounding factor we learned last class. But the same thing, the same factor in a discounting process is called a discounting factor because the role it plays is different. So discounting factor, compounding factor, formula-wise the same thing. Number 1 plus a rate. Since in this case, interest is compounded monthly, the discounting factor is number 1 plus monthly interest rate. Okay, so what is our monthly interest rate? Monthly interest rate is annual interest rate divided by 12. Annual interest rate is 6%. Divided by 12 is 0.5%. 0.5% is 0.005. And 1 plus 0.005 is 1.005. So that's our discounting factor. We got our discounting factor. And from the future value of the account, our financial goal here is 20 grand. We go back, we want to know how much money we deposit today can give us 20 grand in the future, in 5 years. And we reverse the process. So we're going to have a discounting process. In the discounting process, we divide the future value of the account by the discounting factor. Okay, we multiply by the compounding factor in the compounding process, but we divide it by the discounting factor in the discounting process. Here, the discounting process factor is 1.005. For how many times? 5 years, and the interest is compounded monthly, so 12 times a year. For 5 years, 60, right? 12 times a year for 5 years. So the total number of times the interest is compounded is 60. So we divided the future value 20 grand by the discounting factor 60 times. That's how do we have an exponential expression in the denominator. And then we can use a calculator to find the result. 20 gram. Give it a little bit of time for the app to load. Okay. Second mode, clear. We have 20 gram. 1, 2, 3, 4. Future value, right? The accumulated balance you want the account to have in 5 years. Divide that by, I'm going to use a parenthesis to frame the whole denominator. The denominator is going to be an exponential expression. It's going to be the 60th power of the discounting factor. The discounting factor is 1.005. Remember that? And then we raise the discounting factor to the power of 60. That's how many times the interest is discounting, right? From present value to future value, compounding. From future value to present value, discounting. And then close the parentheses. So whatever inside the parentheses, that is the denominator. And that would be the amount of money we're supposed to deposit today in order to have 20 gram in 5 years. Okay, yeah, this is how much we need to invest in the account that pays 6% monthly compound interest. Let me copy the number. Okay, 1418. Is around equal to 14827.44392. 44392. Okay, so in Pearson, when you encounter a problem of this kind, you will see a sentence in the parentheses to instruct you how to run the result. It will say round up to, very important, okay? It will say round up to the nearest dollars. Let's say the nearest dollars. Maybe sometimes ask you to round up to the nearest cent. Would be same idea, okay? So if we need to round the result up to the nearest dollars, we have to follow the instruction, really round up to. If we follow the normal rounding rule, let's see. If we follow the normal rounding rule, look at the digit behind the decimal point. It is less than 5, right? So we're supposed to round it down. If we follow the normal rounding rule, we should round this number down, and the result would be $14,827. However, the question would instruct us to round up to the nearest dollar. So when the question requires you to round the result up to the nearest dollar, you don't have to, worry about the value of the digit behind the decimal point. It doesn't matter. Is it less than 5 or bigger than or equal to 5? Doesn't matter. You have to round it up. You have to round it up. Then the result would be $14,828. I hope I have your attention here, because part of the class are not enrolled in the essential. In the essential, I think I remember I mentioned this, but for the QR class, we didn't get a chance to cover this part. May I have some response? Is that clear, guys? Regardless the value behind the rounding place, bigger than 5 or equal to 5 or less than 5, doesn't matter. You have to round it up because the question says round it up. Even here is a 4. Normally we round it down, right? But here we round it up. So $14,828. Very important. In the past semesters, every semester, there are students messed up the second exam because of that. Even I emphasize many times. I have no idea. Are they not listening to me? I really make this very clear. right? This is the first time we mention this. I'll keep trying, keep mentioning the same thing, repeating the same thing. Very important. Let me explain why. Because if we follow the normal rounding rule, in this case, if we follow the normal rounding rule, we round it down, then in 5 years, we will fall short to reach the 20 grand goal. Maybe we'll have $19,999.99, blah, blah. But we'll fall a little bit short. So in order to guarantee the financial goal is achieved, we round it up. We round it up. That's the reason, okay? Yeah, so normally if we are given the present value and we are looking for the future value, we follow the normal rounding rule. How much money would you have in the account? In that case, we follow the normal rounding rule. But if we are looking for the deposit, the money for today, in order to reach a certain financial goal, in order to guarantee the financial goal is accomplished in the future, we have to always round it up. And you don't have to worry about when to round it up, when to just round it to. The question will tell you, okay? In the parentheses, they will tell you. If you see round to, that is, then you follow the normal rounding rule. If you see in the parentheses, it says round up to, then you have to round up to, right? Yeah, follow the rounding rule. And the last topic of this section is about effective rate. Effective rate has a different name on our book. It's also called effective annual yield. Yield, the initial is Y. That's the reason in our book we use the capital letter Y to represent the effective annual yield. It's also called the effective rate. I will not prove the formula. I'm not sure how much that can help you. I will explain how this effective rate works in reality. So one of my table notes, let's go to my table notes. Yeah, this picture is, by the way, is in Blackboard. Okay, all the materials, all the resources are posted in Blackboard already. So I'm talking about this picture in my table note. This picture is to explain the application of the effective rate in reality. In real world, you must have heard of APR, right? At least the APR you heard of. Because when I watch the TV, sometimes it has commercials about a car from a dealer. It will always say, how many percent APR, right? 0% APR or 1% APR. And what does APR mean? What does APR mean? APR stands for annual percentage rate. APR is our effective annual yield, or just the effective rate, our big Y in our book. All right? It just have a different name in reality when it comes to a loan. And I'm not sure if you ever heard of APY. Maybe some of you did. APY stands for annual percentage yield. That's the terminology people use when it comes to investing money. So the same thing, APY also is the same with our effective rate. So basically the three things, the same thing. Effective rate on our book, APR when it comes to borrowing money, or APY when it comes to investing money. All the three things refer to the same thing. That's the actual rate, effective rate. Then how do we? Then what is the rate we have when we handle compound interest problem? This little r, and this is effective rate. Then what is this little r? This little r is called a nominal rate, like a name-wise on surface. The effective rate equal to the nominal rate when n equals 1. When the interest is once a year. But if n is bigger than 1, if the interest is compounded semi-annually or quarterly or monthly or daily, in that case, the effective rate is bigger, and not much bigger, a little bigger than the nominal rate, because it has a compounding factor here. You see this compounding factor? Because it has a compounding factor here. All right, so let's find a problem that we can actually understand, at least understand the concept of the effective rate. I think this is a good one. A passbook savings account has a nominal rate. You see that? I just explained what is nominal rate, right? And so far, in the previous problems, when we talk about R, we said R is the annual interest rate. That is a nominal rate. Okay, that is a nominal rate. This is our little r. This is our little r. Annual interest rate. Here we specify it is nominal to differentiate from, the effective rate we are going to talk about. We are looking for the effective rate. The interest is compounded daily. If it's annually, we don't have to do anything, because if the interest is compounded annually, the effective rate is the same with nominal rate. But in this case, the interest is compounded daily. Then the effective rate is supposed to be a little bit higher than the nominal rate. So we are looking for the account's effective annual yield. It's the same with the effective rate. I like to use the name effective rate because, effective rate, nominal rate, right? They are closely related, and they basically play the same role, but they are different. Effective rate means the actual rate. Nominal rate is like on the surface. All right, what's the formula? The letter that represents the effective rate is capital Y. Y equals 1 plus R over N. Remember, this is the compounding factor. Okay, we're going to raise the compounding factor to the power of N, because the interest is compounded N times a year. So over 1 year, and that's how many times the interest compounded. So we raise the compounding factor to the power of N, and then minus 1. So that's the formula for the effective rate. When you working in your MyLab math, they would always give you the formula. They will not give you that specific formula. They give you 4 formulas, and then you choose the correct one from the 4 formulas. And you're gonna at least know which one to choose from. All right. Now let's plug in the values for the variables. R, the nominal rate, 5%. In decimal, 0.05. N is 12 because the interest is compounded monthly, so N equals 12. Okay, let's plug in 1 plus 5% over 12 to the power of 12, and then minus 1. You can use whatever the calculator available to you to figure out a way to evaluate the expression. I'm going to use the TI-84 calculator. I like to play like this. I'm going to enter the whole expression in a calculator. You don't have to. It's just one option. You don't have to, by the way. I like to play with it. I start with the parentheses. Hi, Charlie. It was compounded daily. Oh, did I mess up? Huh? Oh, this the other one. Yeah, I'm sorry. My bad. Compounded daily, not monthly. The previous one is monthly, right? Sorry about that. My brain kind of wandered earlier. I apologize. It's daily. Daily, so N is 365. 365. Thank you for letting me know, Charlie. Monday, today's not Monday, but my Wednesday similar with Monday, same schedule. Thank you. The problem is 360 days in a year. Would that n be 360? Let's read the question. Oh yeah, exactly. 360. It says that. It says so. 360. 360. All right. So let's enter the expression in the TI-84 calculator. I'm gonna start in the parentheses. That is going to frame the compounding factor. 1 plus daily interest rate. Daily interest rate is the annual interest rate, which is 0.05, divided by the number of days in a year, 365, right? And then close the compounding factor and raise the compounding factor to the power of 365. Let me start over. Sorry. Start the parentheses. 1 plus, I actually can get another set of parentheses. Annual interest rate 0.05 divided by 360. In our guided note, it introduced Banker's rule. This is the Banker's rule. It's pretty interesting. I would recommend you read that paragraph to see how smart the bankers are. So this set of parentheses frames the daily interest rate, which is the annual interest rate divided by 360. And then now I'm going to close the bigger parentheses that frames the compounding factor. And then I'm going to raise it to the power of 360 and then minus 1. One benefit of doing this is you can see what you entered. Another disadvantage is you really have to know how to do this. If you miss a left-handed parenthesis or right-handed parenthesis, or you incorrectly express the structure of the expression, and you will not have the correct answer. Okay, this is correct for sure. And the result is 0.05. Let me see if I can copy paste the result here. Here. Okay, very good. And we are going to round it to, it doesn't say, right? How about round it to the nearest hundreds? Then we are going to, so firstly, we're gonna move the decimal point to the right twice, and then keep 2 decimal places. Then this is a 6, so we round it up. We have 3 here. So the result is 5.13%. Yeah, look at the value of the effective rate, 5.13%. It is higher than the nominal rate, right? Nominal rate is 5%. The effective rate is very close, actually, but more than that. Okay, if you have a number, the result less than 5%, that means you got it wrong. Or if you have a number like a lot bigger than 5%, then that doesn't make sense either. The result is going to be very close to the nominal rate, but a little bigger, like this one. All right, guys, that's about effective rate. Yeah, just to know, in reality, when you hear people say APR, APY, that is just the effective rate we learn in a class. Okay, it basically represents the actual percent increase. This is actually percent increase. Actual percent increase, taking the compounding effect into consideration. It is different from the nominal. It's higher than nominal. All right, guys. So that's everything about compound interest. So we finished 8.3 and 8.4. Today we scheduled to cover 8.5. In 8.5, we are going to learn a different type of investment account. It's called annuity. All right, annuity. What is an annuity? Annuity, it refers to an investment account. All right. The name is called annuity. And what is an annuity? An annuity is a sequence of equal payments made at equal time periods. And IRA or Roth IRA are examples of annuities. So annuity is a way to invest, and the way to invest fits most of the people, because you just need to deposit a fixed amount of money at an equal time period. For example, you invest $100 every month. Yeah, a lot of people like this way, right? Every month, how much money put in, or you invest in 500 every quarter, or you put in 1,000 every half a year, or you put in 2,000 every year, right? So people like this type of investment process, and that kind of account is called annuity. All right. So we have two types. There are two types of annuity in reality. One is called ordinary annuity. The other is called annuity due. What's the difference between those two types of annuities? In an ordinary annuity account, the investor deposits the same amount of money at the end of each equal time period. For example, deposit $100 at the end of each month, right? Or $2,000 at the end of each year. So ordinary annuity, the keyword here is end, END. In an annuity due account, the investor deposits the same amount of money at the beginning of each equal time period. For example, put in $100 the first day of each month, or put in $2,000 January 1st, right? The beginning of each year. So the keyword for annuity due is begin, B-E-G-I-N. We do not talk about annuity due. We only cover ordinary annuity. So when we see annuity in this section, that is default as ordinary annuity. That means the investor deposit the payment at the end of each time period. Is that clear, everybody? It's just a way to invest in money, and pretty comfortable, right? Most of people can do it. Okay, very good. And another important definition we need to know is the value of an annuity. When we talk about the value of an annuity, it means the future value. I'm going to write FV here. All right, when we talk about the value of an annuity, that is the future value of the annuity account. It is the sum of all deposits with all the interest paid. Another very important thing we need to know about annuity is there is $0 in an annuity account at the very beginning. At the beginning means you do not need to deposit anything to open an annuity account. You don't need to contribute or commit to anything when you open an account. You don't have to deposit. You do not have any money in the account at the very beginning. Okay, since we are talking about ordinary annuity, so your annuity account has no money until the first payment is deposit the end of the first month or the end of, depends on how you invest in the account, or the end of the first the every year, right? So does that make sense? So there's no money in the annuity account when we get it started. Is that clear, guys? Yeah, let's say you want to put $100 in your IRA the end of each month. Again, we are talking about ordinary annuity. So when you open the account, you have no money, and the account remains no money, remains empty until the first payment is deposited the end of the first month, right? And then, since annuity is a savings plan, the account will pay you compound interest rate. Okay, will pay you compound interest. So every time you deposit, so the pay you compound interest, and the way the interest is compounded is consistent with the frequency you deposit your payment. For example, if you deposit the payment once a month, the end of each month, then the account will generate interest, will compound the interest monthly. If you deposit your payment the end of each year, right, then the account will compound the interest once a year, so annually. Does it make sense? So I just want to make sure that we understand the idea of annuity. It's pretty important. It's different from an account, just different from an account that you deposit one paycheck at the very beginning. In section 8.4, all the questions is you deposit one check and then you forget about it, right? And how much money you will have in 5 years or 10 years. But annuity takes a little bit of effort. Good news is you do not need to contribute anything in the very beginning. But you do need to deposit the payment, equal payment at an equal time period. It depends on how you choose it. Okay. And let's see examples. This is the formula. This is the formula to calculate the value of an annuity if the interest is compounded annually. And the formula that is used to calculate the value of an annuity if the interest is compounded n times a year is this one. I do not recommend you use the formula. You're welcome to use if that's a good method for you, but I do not recommend, because how do you understand the formula? You don't really understand it, right? It takes me a while to derive the formula. So basically, meaningless doesn't really help. So we are going to use the TI-84 calculator. We are going to use the TI-84 calculator, the finance application in the TI-84 calculator, to process problems that about annuity. Let's look at this problem. Oh, I didn't mean to do that. Did I not enable the editing? I did. Two parts. Okay, we can just look at this. At age 25, to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. Find the following answers rounded to the nearest dollar. Part A, how much will you have from the IRA when you retire at age 65? So this is to find the value of the annuity. IRA is an annuity in the future, right? And part B, find the earnings from this investment, the interest. Okay, let's do one part at a time. Let's see, what do we have? So the interest rate, annual interest rate is 7.5%. Let me highlight the information we have. Okay. And how does the account compound interest? The interest is compounded monthly. Remember I said how the interest is compounded is consistent with how you deposit your payment, right? And you deposit your payment also by month, the end of each month. Okay, so it's also monthly. You deposit $200 at the end of each month, so it's an ordinary annuity. $200 is your payment, PMT. And in the formula, it is P. So it's weird, right? It's better use PMT because we had this letter represent the principal in previous sections. So I really think this one should both be PMT. But if you prefer using formula to do the problem, just know P here refers to payment. In our problem, in this problem is $200. All right. So let's see how many years. Age 25, you start the annuity, and you want to get the money. You want to know how much money do you have when you are it's right here, 65. 25, 65, 40 years, right? T equals 40. Yeah. So if you use the formula, just know A is the value of annuity. It is the future value of the account. P is the payment, not principal. You do not have a principal. Technically, you do not have the original principal because your annuity, it has zero money in the very beginning. So P here represents payment, $200 in this problem. N is 12, right? Because by month. R is the annual interest rate. T is 40 years. And if you use the formula, then that's the meanings for each variable in the formula. But we can get it done with a very efficient tool, right? The app in a calculator. The reason I recommend the app is also because in reality, it's weird that you use a pencil and find a formula and plugging in, right? But you can use a financial calculator. The financial calculator is very similar with the financial application in the TI-84 calculator. You can go to the website of a bank. You can see it's very similar. If we know how to use the app in TI-84 calculator to handle those problems, you would be able to understand their financial calculator very easily. Okay, let's see, how do we do that? All right. Remember in the TVM solver, we have the following entries to determine: N, I%, PV, PMT, FV, and O's. I need more space here. And P per Y, C per Y, right? Okay. Oh, also, you would have like a begin END here and a begin BEGIN here. All right, payment. Yeah, look at your calculator. All right, so let me explain how do we understand those entries in the case we have an annuity account. We're investing, and the capital N here is the total number of times the interest is compounded over the lifetime of the annuity. So I don't mind to write it down. N here is the total number of times, number of times of the interest is compounded each year. All right. Oh, sorry, my bad. Not each year. Over the lifetime, compounded over the lifetime. Over. I apologize. My brain is a little bit tired today. Over the lifetime. Over the lifetime of the annuity. All right. So in this case, 40 years. Over the 40 years, how many times? Yeah, what's the total number of times the interest is compounded over the 40 years? It is also the number of payments. Yeah, number of times you deposit your payments. Number of times you deposit your payment. You deposit $200 end of each month for 40 years, right? So what do you think? What's the value of N? You deposit the end of each month for 40 years. What's the value of capital N? Hello? Are you guys there? Yeah, how do you get that? Exactly, 12 times 40, right? That's correct. Very good. 12 times 40. 12 times 40. 480. Awesome. Yeah, a lot of payments because 40 years, half of the life, right? How many 40 years a life has? So that's capital N. That's how do we understand the value of N. Next one, I%. I% is the annual interest rate. Here again is a nominal, all right? Nominal interest rate is 7.5%. So you just need to enter 7.5 here. Anybody remember what does PV stand for? What does PV stand for? PV. Present value. Awesome. Okay. Means the money in the account, the very beginning, right? Okay, you tell me. For an annuity, how much money do we have at the very beginning? Awesome. Thank you, Charlie. You guys are awesome. Thank you, Jennifer, Ashley. Means you are paying attention. I appreciate that. I need to be careful that do not misspeak anything. Okay, yes, exactly. For annuity, the PV always 0 because there's no money. There's no money when you open an account. Remember, in this case, the account is going to remain $0 in it until the end of the first month. You have $200, right? Okay. PMT here stands for payment. PMT here is a payment. And this entry is new to us. We did not use this entry in previous section, right? PMT is the how much money you deposit, right? You deposit 200. Since you put the $200 in the account for a long time, and is the $200 is leaving your pocket. So I would say the payment is going to be negative 200. Negative 200. And if you know PV stands for present value, then you would know FV stands for the future value. Future value is the number, is the variable we are going to solve for, right? Yeah, we want to know the future value. How much here? Remember I said I always put a 9999 to hold a place and remind myself later I'm going to go back and to solve for future value, right? All right, P per Y. Per Y means per year. P is the number of payments. P per Y means the number of payments a year. I can write it down. P per Y is the number of payments per year. C per Y is the number of interest is compounded per year. Yeah, the number of times the interest is compounded every year, compounding period every year, right? In this case, 12. You deposit $200 12 times the end of each month every year per year, and then your interest is compounded 12 times a year because it's a monthly, right? So P per Y, C per Y, remember the two values are always equal to each other? Yeah, they are 12 in this case. And now let's look at the last row. It will show end or begin, right? Yeah, let me see what's the actually. Yeah, PMT, I was right. PMT but colon here, not equal sign. PMT. PMT. The calculator default END. If you don't change it, it's default as END. Means your deposit is your payment is made the end of each time period. In this case, is end of each month, right? So END is supposed to be selected. I mentioned earlier we only cover ordinary annuity, so we always use END. We never use begin, unless you're talking about an annuity due. The payment is made at the beginning of each time period. You choose begin. In previous semester, every semester this happens. A student asks me, everything is the same with mine, but the result is different. Now I say check the last row. Check are you using ordinary annuity or annuity due. We only talk about ordinary annuity, so you need to have END selected. Oh, then fix this and the result the same, right? Okay, and then we go back future value to solve the future value. Now let's use the actual calculator to do that. This problem, let's remember the information, 7.5%, 40 years, monthly, $200. Okay. This is the main page of the calculator. We go to apps and then finance, TVM solver, and we have this here, right? Yeah, capital N, total number of times the interest is compounded over the lifetime of the annuity. 12 times a year for 40 years, so 12 times 40. I%, I remember it's 7.5. 7.5%. PV, remember annuity, PV always equals 0. There's nothing there at the beginning of the very beginning when you open the account. PMT, $200. Since your money is leaving you, negative 200. Again, this is negative. Do you see my arrowhead? The large pink. This is negative. This is minus. You do not use minus to represent negative. Otherwise, the calculator shows error. So negative $200. Yeah, every month you contribute $200. $200 is leaving your pocket. For the future value, we don't know how much. We're gonna solve for it, right? I always put the 999 to hold the place. P per Y, the number of times you deposit your payment per year. You deposit $200 the end of each month, so 12 times a year. Same with C per Y. C per Y is the number of compounding period per year. The compounding period is a month, 1 month, so 12 months a year, so 12. And as you can see, END, right, is defaulted as selected. We never use begin. Again, we never use begin. We only use end. Go back to 9999 and then solve for the future value. Alpha, enter. Okay, it's a positive. That means in 40 years after you retire, those money gonna go back to your pocket, but you're gonna pay tax on it. You're gonna pay income tax on it. But suppose your income is lower, your tax bracket is lower, so you might end up with paying less tax, right? And also the future money worth less, so the future tax worth less generally. So let me copy paste this number. 6 this. Depends on how the problem requires you. You run the number properly. Put it here. Okay. So the future value of the annuity, if we run it to the nearest cents, and we have 604,764.43. Run it down because this 4 is less than 5, right? 604,764.43. So that means in 40 years, you are going to have a lot of money. You're going to have $604,764.43. You're going to have a lot of money, right? For your retirement. Yeah. Not sure how much money. I'm not sure how inflation works, how bad the inflation is going to be in 40 years. But that's how much money you're going to have. Is that clear, guys? Yeah, I really do not recommend you use the formula. What's the point? Do you really understand the formula? I have to take a while in order to figure out what's going on in the formula, right? Of course, it's a good practice algebra-wise. It's a good practice algebra-wise. But more important, I want you to understand the meanings of those variables. And then in reality, our app is very similar with the finance calculator. It will help you better, okay? Use this method will be more beneficial. No, but I will go back to look at the recordings. What is no? Not very clear, Crystal. This is the first time we use the app for annuity. We'll practice more. All right, we'll practice more. Also, later in the essential session, we'll practice another 50 more minutes. Yes, just need to practice more. Yeah, watch the video more times. Yeah, how do we actually learn something we are not familiar with? Repeating. Anything that you are familiar with right now is probably, if you recall, you probably already repeat the thing many, many times. It really depends on you repeat. I don't understand the formula either, but I do understand the app. Yeah. Again, I do not recommend to use the formula, but I cannot say you are not allowed to use formula, right? Because this is still a math class. You use the formula, at least you practice the algebra. But what you can lose by using my method, by using the app? There's nothing you can lose, right? Yeah, I really do this for you. Think about other, if you enroll in a professor's class, they do not allow you to use the app. You have to use the formula. It's very likely you messed up. It's very complicated. Very complicated. Okay, we have another part. Find the earnings for the investment. Yeah, the earnings here means interest. Let's use common sense. Okay, let's use common sense here. Money going out, leaving your pocket, and the money coming back in the future. Okay, let's figure out those two things. Over the 40 years, how much money went to the account? Yeah, how much money leaving your pocket? Okay, how much? $200 every month times 12. That's how much money you invested in the account for a year, for 40 years, right? Yeah, that's how much money you put in over the lifetime, over the 40 years. How much is that? Let me quickly calculate, use the scientific calculator. $200 every month times 12. That's how much money you put in a year. times 40. That's how much money you put in the account over the 40 years. 96,000, 96 grand. 96 grand. 1, 2, 3. Then let's see how much money coming back in the future. In 40 years, you will have this much money we got from part A, right? Yeah, you will have $604,764.43. You have a lot more. If you look at that, 5 times, 6 times actually, 6 times more. But that is a 40 years effort, right? Do you agree? Do you agree? The difference between the two amounts, you have more because you are investing, right? It's a very safe way to invest in money. It's not like the stock market. You probably end up with money come back less than money going up. But this is a very safe way to invest. So the future value is more than the money you put in. So we use 604,764.643 to minus 96 grand. Oh, sorry, 96 grand. 1, 2, 3. 96,000. Then we would have $500,000. Yeah, 200 every month, 12 months for 40 years. 96 grand. But in 40 years, you have this amount. Let me just double check. Is that 7.5? Oops, sorry, enter the wrong button. 7.5. Yeah, 7.5. 7.5 is really high. 7.5 is very high. And 12. Yeah, it is correct. Simply, the interest over the 40 years is $500,000. That's a lot, right? This is very good invest. Is that clear, everybody? Does that make sense? How do we find the interest? Very good. Okay, perfect. So as I mentioned last time, in this culture, in American culture, people more like to set up a financial goal, right? It's not like my culture, we just save whatever we can. In this culture, you have a financial goal when you retire, how much money you want to have in the account. Then you decide how much payment every month or every year to put in the account, right? So let's look at a problem that funding the payment that pays 6%. Let's see. You make regular pay monthly deposit in and you pay 6%. How much should you? Yeah, this one is about that problem. Let me insert a page break. 2 questions here. All right. Let's see. Suppose that once you complete your college education and begin working, you would like to save 20 grand over 5 years to use as a down payment for a home. You anticipate making regular end-of-month deposits in an annuity that pays 6% compounded monthly. Part A, how much should you deposit each month? So in this case, we are looking for payment. Right? More practical in reality. We want to know how much to deposit every the end of each month. In order to have 20 grand, so that's future value, FV, in 5 years. So T is 5, right? Maybe in 5 years you want to go on a trip, right? Then in order to reach that financial goal, how much you will deposit every month? in an annuity in order to have 20 grand. Okay, so let's see. We use the app, right? We have capital N, we have PV, we have PMT, we have FV, we have, oh, I missed a I% here. Apologize. Capital N, I%, PV, PMT, FV, P per Y, C per Y, PMT, end or begin. All right. So let's see what do we have for this problem. Hello? Hello? I'm so sorry, I don't know what happened. I was asking a question, but no answer. So I look at it and then notice it's disconnected. Oh, thank you. All right, thank you for staying. And we are trying to figure out the values for those entries, right? Present value for annuity is 0. PMT is something we're going to figure out, right? So I can put a question mark here. Future value, we want a 20 grand. So 1, 2, 3, 4. P per Y, C per Y is going to be 12 because the payment is deposit the end of month, the end of each month, right? Okay, so those are the entries we need. I'm not sharing. Okay, let's do it again. Sorry about that. Okay. Okay, now I'm sharing again. Sorry about that. So let's enter the values. So 12 times a year for 5 years. 40 is only 5 years for not that big of financial goal. So I% is 6%. Present value for annuity is always 0. Payment is what we need to figure out, right? So I put a 99 to hold the place. Future value, we want a 20 grand. 1, 2, 3, maybe for the trip, right? P per Y, C per Y are both 12. And it's ordinary annuity, so we have E and D highlighted. Go back, PMT, and we alpha enter, solve for PMT. Negative, right? Means in order to have 20 grand in 5 years, every month, you have to, the end of each month, you have to deposit around $267. And this is something the question will require you to round the result up. Okay, round up the result. Let's say we round up the result to the nearest dollars. So the payment is around equal to 287. Yeah, by following normal rounding rule, we need to round up anyway. But we don't really need to know the digit bigger than 5 or less than 5. We round it up anyway. It's to guarantee the financial goal in 5 years will not fall short. All right, guys? Yeah, mainly is you know how to calculator. Yeah, end of every month, $287. In 5 years, you have 20 grand. Yeah, for down payment. Okay, this one actually has a purpose for down payment for your house. Very good. Is that clear, guys? And the part B, how much of the 20 grand down payment comes from your deposit, and how much they come from the interest from the bank. Okay, let's finish this one. Okay, let's finish this one. So let's see how much you have put in. You deposited 280. The result we got from part A, $287 every month. Yeah, times 12 is how much you deposit 1 year, times 5 is how much you deposit over 5 years, right? So let's do the calculation on the calculator. 287 times 60 times 12 times 5. $17,220. $17,220. $17,220. That's how much money you have put in, right? In 5 years, you have 20 grand. And the difference comes from the bank. The difference is $2,780. And this is the interest. How about that? Yeah, that is the interest. This is the interest. Yeah, you put a majority of the money, and then the bank put in $2,780 to make the 20 grand in 5 years. All right, so that's our practice for today. Sorry about the connection. I don't know, maybe I entered something wrong. I'll see you. Today is Wednesday. I'll see you on Monday, guys. I'll see the essential session in 10 minutes. See you. Bye-bye.